All right, this is part one of quantitative analysis. We're going to start off looking at descriptive statistics. So there are three kinds of statistics. The first is descriptive, and this summarizes data. The other two we'll be talking about in other videos, but that's correlational and inferential statistics. So starting with descriptive data we use to describe central tendency. This is the mean, median, and mode of our data set and describes our sample. And then we also will look at frequency distribution. This has to do with how the data is distributed around mean. And this is important because if we do not have a normal distribution around the mean, then we may not be able to perform other more advanced statistical analysis. And then we look at variability and how the data ranges. So very quickly, we'll look at central tendency. First, we have the mean. This is a computed average. The median is the midpoint of a score. I often will report this when I talk about how people have done on the quiz. I may report the average or the midpoint, because if you have a few data points that are much higher than the average, it skews the average one way or the other. And then the mode is the most frequent score that you might have in your data set. So these are three different important elements of central tendency. Here we have two schools with the same mean, and that is a score of 100. But you can see the distributions are very different. In the first, we have a high number of people with the same score. That's like a mode of 100 perhaps. And we have a much narrower range. In the second, we have much more variability around that median. So you can see the pattern of distribution really does give you quite a different picture of your data set. Here's some skewed distributions. We call it a positive skew when there's a large number of high scores. So in this case, what you're seeing here, the reason it's positive is that rather than this normal distribution where it would end here, we have all these scores on the positive end of the scale. And here's an example of a negative skew. And once again, if this was a normal curve, it would go down here. And we have instead a high number of negative or lower scores, which end up skewing the data. All right, and then here we have unimodal and bimodal. Unimodal means there's simply one bump in your frequency, and bimodal means there's two. So pretty easy, but you can see, and you will see descriptions of data using these terms, unimodal and bimodal. Then we have another way to show the frequency of data. In this case, we have two variables. The one is smoking status. The second variable is gender. And so we have two different genders here, and we have three different smoking statuses. And then we look at those two variables across each other. So where the two meet, that's where you see the score here. And you can look at a crosstabs table and recognize some important differences. For example, there's a higher percentage of this sample that includes non-smoking women. This is just many ways that you can look and understand data. Finally, the third term is variability, and this has to do with the way the data is distributed around the mean. So it takes every point in and looks at it as a standard deviation from the mean. So we have a positive standard deviation, a negative standard deviation contains 68% of the observations. And then if we get, so that would be two standard deviations around the mean. If we look then at 4 standard deviations, 2 negative and 2 positive, we get 95% of the observations are within this range. And And then when you look at 3 standard deviations from the mean, we have 99.7% of the observations are within that range. So this is the way that researchers describe their data. This kind of description can be found both in quantitative and qualitative research. So know that descriptive statistics could be reported in either type of study. So the reason they're important, it's the starting place for all other statistical tests. If we don't have a normal distribution around a mean, we may not want to use other more advanced statistical tests. So it's important that you always run the descriptive statistics first before you do other tests. So when you're reading about research, if the authors have done more advanced inferential statistics and do not report that their data had a normal distribution around the mean or unimodal distribution, then we might question their choice to move on with the inferential statistics. So that's all for this